Today we're going to explore and investigate the difference between water and air and how they can and cannot be compressed. And so we're going to use a science toy that's been around for actually a long time, hundreds of years. And the science toy we're going to use is called a Cartesian Diver. The Cartesian Diver is actually named after this guy right here. And his name is René Descartes. He's a French philosopher and mathematician. And he came up with not only this, making the Cartesian Diver popular, he is also known for a math system that you use, which is the grid system right here. And this is called the Cartesian grid system with the XY axis, plus and minus, and you use this in math. So he is known for both of these concepts, the Cartesian Diver and the math coordinate system with plus or minus XY axis. But what is a Cartesian Diver? Cartesian Diver has to do with the difference between how air can be compressed and how water cannot be compressed, basically. And so let me show you, I have here a little Cartesian Diver that you might see. It's right here inside of this 2-liter bottle, and it's a little glass floating device that has water and air in it. And when I squeeze on the sides of the bottle, I can make the diver go down. And when I let go, it goes back up. So a Cartesian Diver, when I squeeze it, it goes down. When I let go, it comes back up. And we're going to make one of these today. In fact, there's a variety of ways to make these. Here are some that I have made with a plastic barrel pipette and a 1/4 inch hex nut for weight. And you notice the more I squeeze them that these are different buoyancy levels because it has to do with how much air and water is in each of these little divers that look like this. One thing, a lesson today, is that air will compress and water will not compress. Now, what I mean by that is that air, if you have a strong container and you push air and pressure down, the air will take up less and less space. It's a gas, and so we can squeeze it down, add more pressure, and squeeze it down into a very small space, and then we have what's called compressed air. Okay, you know, the air pressure is different depending on where you are. For example, if you are, if we had here basically flat land, and then we have a deep valley, and then we back up to flat land, and we have a high mountain, okay, snow-covered mountain. And if the atmosphere, air, is above us, it's pretty easy to understand. If you're standing here, you have a certain amount of air pressure above you. And if you're way down here, you might have more air. You can see how you have more air above you, a different pressure. And if you are at the top of a mountain, climbing a mountain, you have even less air. So the press of air, or air pressure, changes on how much air is being exerted on you. Air can be compressed. I've been scuba diving before, and when you go scuba diving, self-contained underwater breathing apparatus, you take a tank of air with a hose and a regulator. The interesting thing, when I go down about 33 feet, 1 atmosphere, if I blow a bubble of compressed air, as it goes up, it gets larger and larger and larger till it might be that large at the surface before it bursts into the atmosphere. Because when I take a bubble that's down low, that's compressed air, and it gets bigger as it goes up. Same thing happens with a balloon, like a weather balloon, or a weather balloon that we fill up here on the Earth about this big. As it goes up, it expands because there's less pressure. Air can be pressed. You came to school today probably in a car or a bus or a bicycle, and inside of every one of those tires, air has been pressed in there. My car is about 32 pounds of air per square inch to keep my car up. So we can press air. In the Cartesian Diver, there is a small amount of air inside of the top part of it. And when I squeeze on the side here, I squeeze, I mean, you can see I squeeze that water that exerts a pressure up inside of it and compresses the air, making it less buoyant, and down it goes. So air will compress. Water will not compress. And what I mean by that is that same container that we had air in, that you can squeeze down and compress, you can still squeeze water, but it's not going to compress. It's going to find a way to go out. For example, a pipe right here. Let's say we had a pipe, and the pipe has an opening like this and comes down, okay? Here's a 45-degree angle on this pipe. And this pipe comes over here, and it has another 45-degree angle going back up. Okay, if I filled this pipe with water, okay, it's filled with water, and I could press it down, water is going to come out, okay? If I push down, force down, water is going to come out. Now, if I close this lid and press, no water is going to come out, and I won't be able to press down if I had some sort of a piston or a container to press it, you won't squeeze it. However, if I put in here a bubble of air, if I had some air inside of this container, when I push down, this air bubble would get smaller and smaller. So you can compress air, you cannot compress liquids. And because of that, we have a whole system of moving things called hydraulics. Hydraulics is when you use a pump to pump liquid through a pipe to push something up or down at the other end. I was driving to school and I saw a crane and I saw a big bucket, like a bulldozer that has a blade on the front and a front end loader, and all of those had the loader and the bulldozer had a bucket on the front of it, and this bucket was hooked to a arm with a hinge, and this arm was hooked to another arm with a hinge, and then over here it had the operator on the tracks working it. And this machine had this looked like a piston that would push, and this silvery thing right here and the pipes going to it had these pistons that were working off of hydraulics. And so when the operator pushed a button, the pump would pump liquid and push this in and out. So hydraulics help us move things because liquids will not compress, but air will compress. You want to make sure when you have your brakes on your car, the liquid, and when you push on your brakes, it pushes liquid brake fluid through a small pipe that closes on the calipers on your brakes and slows you down. One thing you don't want is air in your brake line. So if you go to push down, nature's going to go where it's easier. You're going to compress the air. I would like to share with you a video that I have that I've had this for several years. It's an excellent video. I'm just going to show you a little bit of it. And it's made by Bob Becker. And let's take a look at it right here to give you an idea of what we're going to be doing. Okay, Educational Innovations presents the Cartesian Diversions. Okay, so you can learn more about Cartesian divers by viewing that video by Bob Becker. They're pretty easy to make. There's different ways to make. We're going to use a plastic barrel pipette that looks like this and a 1/4 inch hexagonal metal nut. Now, if you shop around, you can find that there are different sizes that fit either the pipette or the hex nut. So go ahead and slide those on there like that. And you can either put a piece of tape on them if they don't fit right. What I'm going to do, and this is kind of important, we're going to put these on and we're going to cut off with our scissors, but I only want you to leave about a centimeter space right here. Don't cut them up close. If it fits on tight, that'd be fine, but ours falls off. So I'm going to leave about 1 finger width, or about a little over a centimeter, right over there like that, okay? Now, unfortunately, this will fall back off unless I can cause this to stay on. Now, the tape is not good, clay's not good, but I have another solution. My solution is a crude but effective. What I'm going to do is I'm going to use my tooth to chew on and flare without swallowing. And since it's soft plastic, I can just flare it, and I ended up making it flared like that. See how it's, you see how I flared it? So go ahead, and we're going to cut it off. So there's basically 3 things we want to make sure to be successful. Number 1, cut and flare. Cut and flare the tube so it ends up looking like this. Here's the barrel pipette. Here's my hex nut on it, using it for weight. And then this part is flared out like a trumpet, like an end of a trumpet. Go ahead and do that, please, and try it. That's your step 1 for being successful. Okay, so our first step is to make sure then that our hex nut stays on our Cartesian diver. Our second step, which is very important, is to have a test cup with water. Having a test cup with water is important. Pour some of your water out of your 2-liter bottle into your cup, and here's my test cup right here. And here's what happens when I put this. It's all air, and when I put it in here, you should be able to predict what's going to happen. If it has mostly air, will it sink, be neutral, or will it float high? Let's find out. Ready? And if you notice, it's floating really high because there's mostly air in there. So I'm going to squeeze out some bubbles of air when I do that. 2, 3, 4, 5 bubbles. And now it sinks a little bit lower. It's less buoyant. Here's one that has all of the air in it. See how this one is higher because it has all of the air? Let me see if I can get some more bubbles. There's 5, there's 6, 7, 8. And now there's a big difference in the buoyancy. You can see which one has more air and which one has more water and which one floats higher. If I would continue to do this and push out more air, water replaces it, and now that's kind of a problem. I'll tell you why it's a problem. And this is why this testing is so important. If I put it inside of this 2-liter bottle and it goes to the bottom, I'm going to have a hard time getting it out. There are ways to do it. Use a magnet and pull it up, squeeze it up, but it's kind of messy. So it's very important that you test first in a cup. And you want them to be somewhat buoyant, but not sinking. Now, if it's real high with air, you're going to have to squeeze a lot. If you notice, some of these, they all have different amounts of air in them and water. And so I can just barely squeeze, and some of them go down really easily, and others I have to squeeze really hard to get to go down. And those last 2 have more air, and so I have to really squeeze to get them to go down. There's something else I can do besides just squeezing the bottle. I purchased, this is something you put on a 2-liter bottle to keep your drinks fresh, and it actually pumps air into the container. So what's going to happen if I take this off, the cap off, and I replace it with this flavor saver, which is actually a pump, and all I have to do is pump, and when I pump, I'm increasing the pressure, and so all of the divers go down. And look, they're all at the bottom. And what's going to happen when you can hear this, and I'm going to let the air out. Listen and watch. Ready? When I let the air out, they all came back up, except for that one is a little bit stubborn. And you know what I've done? I've got too much water in that. So that's a problem. To build yours, it's very important for success to use your cup of water. And lid back on, and now I can squeeze the water, which pushes up inside of the Cartesian Diver and causes it to go up and down. The third point to be successful is to fill the bottle with water. Now these 3 points, cut and flare, use your test cup with water, and fill the bottle with water, will allow you to be successful. See, if there's air up here, if I squeeze it and there's air up here, that air is going to compress first before it pushes and compresses the air inside the diver. Nature likes to go where it's easiest. So if you have air at the top, when you squeeze it, that air will compress first. So before you get started, there's some markers. You might want to decorate your Cartesian Diver. I want to make one more drawing to show you what's going on, and then we'll get started. And I can't wait to see how you do this. So here's my little diver with the flare on the end of it here. And it has my hex nut. And that's to keep it weighted. The barrel pipette. Now this barrel pipette has water in it and air. So here's our air. And remember, air can be compressed. Now it's floating in a larger container. Floating in a larger container. And if I just lift the lid off of this, when I put pressure on the outside of this, it won't do anything because all it's going to do is push water out of the top. So I need to make sure that I have a lid on this, and my lid is closed. Now when I put pressure on the outside, it's going to move and put pressure on the water, and the air will compress. When that happens, the diver goes down. When I take the pressure off, this air will expand and the diver will go up. You see, the air acts almost like a spring. Air can be compressed, liquid water cannot, and because of that, we can have some fun with the Cartesian Diver. Hey, I can't wait to see yours. Once you make yours, you can try completing the activities and the worksheet and use it in your own investigation.